Let's take a look at engineering notation. So engineering notation is the same as scientific notation, except all the powers must be multiples of 3, and this is so that it works well with the metric system. So for example, if I have this decimal number here, to put it into proper scientific notation, I'm going to put the decimal between the 3 and the 5, and I count over 1, 2, 3, 4. And because it's a small number, I'm going to use a negative exponent. So I get 3.5 times 10 to the power of negative 4. And remember, in scientific notation, our goal is to have this first number be between 1 and 10. And then this represents the number of times we've moved that decimal point. For this number, we get 62,431. I want the decimal to go between the 6 and the 2. So I move it 1, 2, 3, 4 spaces. And I get 6.2431 times 10 to the power of 4. Again, with this first number being between 1 and 10. Now with engineering notation, what's more important than the number being between 1 and 10 is that we actually want this power to be a multiple of 3. So 3, 6, 9, 12, and so on, either positive or negative. And because we want the power to be a multiple of 3, we're going to be a little more lenient with this front number, and we're going to allow this front number to be anywhere between 1 and 1,000. Essentially what you want to do is count in multiples of 3 and try and get a number between 1 and 1,000 as you go. So for example, in this one, if I go 1, 2, 3 spots, I get 0.35. Well, that's too small. I still want it bigger than 1. And so I'm going to jump another 3 spots. 1, 2, 3. And so I get 350 times 10 to the negative 6, because I had to go 6 spots to get there. So this front number is going to be between 1 and 1,000, and this has to be a multiple of 3. Same thing here, I can jump 3 spots, 1, 2, 3, and I get a number between 1 and 1,000, so I can stop there. So I want you to try these 4, pause the video, and then start it up again when you're ready. Okay, so for the first one, I'm going to count 3 spots, and I get a number between 1 and 1,000, so it's going to be 30 times 10 to the power of 3. Next one, again, I count 3 spots, and I've got a number between 1 and 1,000, so I can stop there. The next one, 1, 2, 3. I get 5.3 times 10 to the power of 3. And in this case, this is also scientific notation. That is perfectly fine. The scientific notation can match the engineering notation. It's okay if they're both the same. And last one, if I go 1, 2, 3, I do not get a number between 1 and 1,000, so I need to go to 6 in order to get a number between 1 and 1,000. So it's 47 times 10 to the power of 6. If you first put it into scientific notation, it'll be one of the multiples of 3 that's closest to the original scientific notation. So for example, in this one, I would do 4 jumps in order to get to scientific notation. And so I'm looking at, is it going to be 3 or 6? Same with here. To get it to be proper scientific notation, it'd be 1, 2, 3, 4, 5. And so it's either going to be 3 or 6. And then 1, 2, 3. So we know that one's right on. And in this one, 1, 2, 3, 4, 5, 6, 7 spots. So I'm either looking at 6 or 9. So if you put it in scientific notation, it will be the closest multiples of 3 to there. You're going to test and see which one gives you a number between 1 and 1,000 in the front.